Alright, so for concept 2, we're going to start on pyramids and prisms. So the main thing you need to remember is that we need to identify the overall shape first and identify the base in order to tell if it's a pyramid or a prism. For pyramids, you could most likely understand what a pyramid is when you see it. As you can see, a pyramid up here, all points are meeting each other. All points are going up to a single point. But as for prisms, it actually has a rectangular shape all around, okay? So that's how we'll tell the difference between a pyramid and a prism. Now we're going to talk about triangular pyramids and prisms versus rectangular pyramids and prisms. So as you can see, for a triangular pyramid, you have a triangular base. The base, the bottom right here, is in the shape of a triangle. As you can see over here, for a triangular prism, the shape is going to be a rectangle, okay? But for a triangular pyramid, the overall shape is going to be this pyramid shape. And for a triangular prism, the overall shape is, you'll see some triangles, okay? Now, rectangular prisms versus pyramid is the main focus of this video. So as you can see, this rectangular pyramid has a rectangular base as opposed to the triangular pyramid, which has a triangular base. Okay, so that's the main difference between the two. Now, if you look at a rectangular prism, it's just rectangles all over. Okay, as you can see over here, there was a glimpse of a triangle, but here it's all rectangles. Okay, so let's go ahead and focus just specifically on the rectangular prism versus the rectangular pyramid. All right. So this is a rectangular prism. As you can see, I have a rectangle, and I kind of start with a rectangle here, and it's like I'm pulling it back. I'm pulling it all the way back in order to create a prism. All right, so as you can see here, how many faces do we have? We have one at the back here, 1, 2, one at the top, 3, one over at the side, 4, one at the bottom, 5, and then we have 6. Then we have 7, and then we have lastly 8. So 1, 2, 3, 4, 5, 6. So we have 6 pieces in total. All right, 6 pieces in total. So what we're gonna do, this right here is called a net. All right. All the net basically means is that we're gonna take a 3-dimensional figure and basically just open it up. Okay. So let me go ahead and erase this so I could explain this a little bit more. So we're going to try to match colors. So the very top over here, as you can see, is purple. That shape is going to be the same as the shape at the bottom over here. So these are both purple. This is going to be the bottom, and then this is going to be the top. Okay? Now we have this green side. That green side here is going to match with the green side behind here. You can't really see it, but it's behind there. So that is going to be side and then side. Okay? And then we have this blue here on this side and then opposite blue on that side. Okay? So I'll just call it like side 2 and then side 2. Okay? So basically, we just have to calculate 3 things and double it. Okay? So when we talk about total surface area, it's the area of all of the faces of a figure, or all of the surfaces of a figure. Okay, so let's actually see this in practice. I have a rectangular prism here. For this rectangular prism, I have a length of 3, a width of 2, and a height of 6. So these two, 1, 2, are going to be the same. It's going to be 3 multiplied by 6. Okay, 3 times 6 is equal to 18, so both of them are 18. Okay, now let's take a look at the top and the bottom piece. That's 3 by 2, so 3 by 2. So 3 times 2 is equivalent to 6, and then that's going to be the same at the top. So as you can see, we're just doubling, right, for some of these. Now we have our sides, which is right here. So it's going to be 6 times 2, 6 by 2. So it's going to be 12 and 12. Okay? So 18 plus 18 is 36. 12 plus 12 is 24. And then lastly, 6 plus 6 is 12. Okay? I'm just going to go ahead and join these because these are just multiples of 12. So I have 36 plus 36 is going to give me my total surface area. So that's going to be 12 72 centimeters squared is the total surface area, meaning the area of all of the surfaces of this three-dimensional figure. Next, same concept, all right? Rectangular pyramid has a rectangle as the base, but as you can see, the overall shape is a pyramid. Now, when I go ahead and break this down in order to calculate its net, you can see that this right here is the base, which corresponds to this here. And then we have our four similar faces. 1, and then 2 at the back, 3 at the side, and then 4 in the front right here. That's 1, 2, 3, 4. And luckily, all of those are the same exact area. It's just the base that we have to calculate differently. So we could calculate for one triangle and then multiply by 4, but it's not always going to be the same size for each triangle. Just be aware of that. Now over here, as you can see, the dimensions of the square is 9 and 9, so the square has a total area of 81 centimeters squared. Now for the triangle, for one of the triangles, it's going to be our base multiplied by our height divided by 2. So our base is 9, our height is 12, so that's going to give us a value of 108. And if we go ahead and divide by 2, we're going to get a value of 54. So it's going to be 54 centimeters squared for one of the triangles. Okay? Now, I have 4 of those triangles, so I'm just going to go ahead and multiply 54 by 4, and it's going to give me a value of 216. So the total surface area for all of the triangles is 216 centimeters squared. Now I'm just going to go ahead and add that to the area of the base, which is 81. So I'm going to get a total value of 297 centimeters squared as my total surface area. Okay? And that's basically how you calculate total surface area. Pretty soon we're going to go over what's called lateral surface area, and that's just the surface area excluding the base as well as the top of a three-dimensional figure. And that's